So besides using prefixes, the second way we can represent very large or very small numbers is to use scientific notation. So for example, a single drop of water contains 5.3 times 10 to the power of 21 atoms. So this is a very large number. If we just use a standard number, then there are 20 zeros after 3, which is very tedious to write. By using scientific notation, we can shows the size of the number relatively straightforward and it's easier for people to understand. So to convert a standard number to a scientific notation, this consists of moving a decimal point and appropriate number of digits. And then we're going to show this shift of decimal point by using a negative or positive exponent. Okay. So a positive exponent, that means 1 times 10 n times, and n is a power here. So this tells you that it's a 5.3 times 10, 21 times. A negative exponent means it's 1 divided by 10 n times. Okay. So in a scientific notation, there are 2 parts, the coefficient and the exponent. So the coefficient need to be at least 1, but less than 10, all right? And then the exponent is 10 to the power of a number, and this number is determined by how many decimals you shift towards the left or right. So now let's look at an example, how we can move decimal to convert a standard number to a scientific notation. So this is a very, very large number, all right? Now, to convert this to a scientific notation, we're going to first find the decimal. So this is a large number, and the decimal is right after the last 0, right? So now we're gonna move the decimal until to the point it gives us a number that's at least 1, but less than 10. So if we want to make this number smaller, right, we have to move the decimal to the left, because if you keep moving to the right, we're making the number larger. Okay, so we'll move it once, and it's not between 1 to 10 yet. You move twice, 3 times, 4, 5, 6, 7, 8. And once you move 8 times, you give us 32.5, right? That's still not between 1 to 10. Then we move 1 more time. It gives us 3.25. So this is the coefficient that we're looking for. It's between 1 but less than 10, okay? And since we move the decimal to the left 9 times, 9 units, so the exponent is going to be positive. So it's 10 to the power of 9. So the scientific notation for this standard number is 3.25 times 10 to the 9th. So keep in mind that when you convert standard number to a scientific notation, the significant figures of the number should not change, because we're not changing the accuracy of the number. So in the standard number, it has 3 significs, and then in this scientific notation, it also has 3 significant figures. Now let's look at another example. So this is 0.000004, right? So now we want to move the decimal to the point we can get a number between 1 and 10, right? So meaning that we'll need to move the decimal to the right. Move 1, 2, 3, 4, 5, 6, and 7 times. We get 4. Okay, so now it's a 4 times, since we move the decimal to the right 7 times, it's a 4 times 10 to the -7. So if you move the decimal to the left, we get positive exponent. If you move the decimal to the right, we get negative exponent. And then feel free to walk through those 2 examples showing over here.